Refrigerated container and controlled atmosphere cargoes. The international transport of temperature-controlled raw materials and final products is an essential link between producers and consumers. Most cargoes have properties that will determine their practical storage life (PSL), which is a key factor if they are to be carried by sea. Claims and incidents. The majority of cargoes are run well, and claims represent a fraction of 1% of the containers carried. Lack of container preparation for loading causing issues such as tainting and lack of general clean lines. Containers have power and therefore off refrigeration for extended times beyond allowed times for power off. Wrong settings due to incorrect information supplied or interpreted. Failure to monitor properly leading to failure to correct false or wrong settings, poorly pre-cooled or overcooled cargo. Cargoes with insufficient PSL badly stowed containers impeding airflow, many with low quality packaging. Use of inappropriate packaging materials. Excess fresh air ventilation. For lift cargoes causing evaporators to ice up. Incorrect defrost interval where this has to be set manually. Incorrectly booked cargo leading to operational and commercial problems. Fahrenheit and Celsius temperature interchange or wrongly converted. Patterns of claims and incidents. One of the main causes of damage to cargo carried in containers is poor stowage by the shipper. Although, as the number of claims is still small, the statistics are difficult to analyze. However, reports indicate a decline in the use of specialized reefer ships and an increase in demand for transport by refrigerated container. Most temperature-controlled containers contain data loggers that record a variety of information. Some are fitted by data transmission capabilities for remote access for both control and readouts. Independent loggers are also available so that a wide variety of audits and checks can be made. When reviewing a claim incident, containers equipped with the information download can show pre-trip inspection records, set point plus supply and return air temperatures at present intervals, defrost, times of power, basic faults, relative humidity. Future trends. The future trends are mainly positive and are likely to include integral containers, more reliable with improved airflow, calibrated air refreshing vents, dehumidifiers, and other programmable settings. Improved insulation with lower degradation over time, reliable refrigeration machinery, controls and data loggers with some providing wireless satellite data transmission and remote access to controls, more use of 40-feet containers making it easy to carry and discharge. New vessels providing faster transits, increasing uniformity of regulations, food standards agencies or equivalent developing in key countries. Majority in container ship operators provide information and guidance through their web-based systems. Principles of Controlled Atmosphere (CA) carriage. CA is a system whereby the gas concentrations to which a cargo is exposed are different from those of normal air. The atmosphere naturally comprises about 78% nitrogen, 21% oxygen, and 0.04% carbon dioxide. The remainder consisting of noble gases, argon, for example. The aim of CA is to change the ratio of these gases. CA is extremely effective on apples and pears, but less effective on some other fruit. In general, it can be said that it gives a 50% increase in storage life and, for bananas, their green life is more than doubled. Regardless the commodity, the strongest influence on the quality of the final cargo outrun is the initial quality of the produce. As well as prolonging storage life, CA also contains the firmness, texture, crispness, acidity, and appearance of some products. It further opens possibilities for the produce to be harvested in a reaper state. The optimal temperature and gas composition for different perishable cargoes depends on variety, growing area, and season. For this reason, the precise values must be defined by the shipper. CA systems currently in use. The two current CA methods are nitrogen gas flushing, fresh air replenishment with carbon dioxide absorption. Nitrogen gas flushing employs air and nitrogen injection to adjust the balance of oxygen and carbon dioxide inside a refrigerated hull or refrigerated container. Air separation units are used to obtain nitrogen. From the outside atmosphere, it is injected to dilute the oxygen in the refrigerated space. If through respiration of the cargo, the concentration of oxygen becomes too low or that of carbon dioxide becomes too high, the system automatically adjusts the gas concentrations. A fresh air exchange system with carbon dioxide absorption relies on the respiration of the product to vary the gas concentrations. When the carbon dioxide or oxygen levels reaches a preset point, the system activates, drawing in outside air to add oxygen and flush excess carbon dioxide as respiration consumes oxygen and evolves carbon dioxide. It is not possible for this system simultaneously to achieve low oxygen and low carbon dioxide levels unless a carbon dioxide absorption system is used. Detrimental effects of CA. Generally, CA is beneficial to the long-term storage of produce, but there can be some less desirable consequences. Inadequate oxygen can result in anaerobic respiration, leading to the production of alcohol and giving the affected produce a characteristic of taste. Excessive carbon dioxide can produce tissue damage and fizzy fruit. In apples, the final effect is a condition known as brown heart, where the core tissue turns brown. Premature ripening of bananas during shipment. Under air stored carriage will turn the fruit yellow, easily identified as cheap ripes. Under CA conditions, however, the raised carbon dioxide concentration prevents the greening of the peel and the bananas arrive with soft pulp, known as green soft or green ripes. If carbon dioxide levels are excessive, bananas may develop a black, blotchy appearance. A combination of elevated temperature and carbon dioxide levels above 5% can even kill the fruit. Safety issues with CA. Safety is an important consideration for carriers because low oxygen atmospheres are incapable of supporting life. Entering an area during CA operation will have fatal consequences, so all CA areas must be clearly indicated by warning signs. Stevedores, chiefs, officers, and crew should be adequately trained to understand the dangers of CA. Doors should be alarmed and adequate precautions taken against stowaways. System failure. Prompt action must be taken in the event of CA system failure. In most cases, the refrigeration system will continue to function, and so complete cargo loss is not inevitable. CA failure can be caused by a variety of faults, such as mechanical breakdown, sensor malfunction, unexpected air leakage, or even exhaustion of a chemical carbon dioxide absorbent. Without intervention, system failure may cause the oxygen to fall too low, causing the anaerobic respiration, and or the carbon dioxide may increase, causing tissue damage. Thank you so much.